Most of the applications that we will see in this course come from electricity. And so we're going to go ahead and look at some simple formulas from DC circuits. We've already seen Ohm's law, and that will be our first example. Okay, previously we wrote Ohm's law as V equals IR. It can also be written as E equals IR, where E is the source voltage or electromotive force. That's where the E comes from. So for example, if I is equal to 4 milliamps and R is equal to 3 kiloohms, and we need to find E. So we have E equals IR. So I is 4, and the milli means that we have 10 to the negative 3. And then R is 3, and the K means we have 10 to the third. So we see the powers of 10 cancel, and the answer is 12 volts. Okay, in our next example, we're going to look at a different formula. The power dissipated in a resistor is given by P equals I squared R. Okay, and usually the power is going to be given in watts. So let's do an example of that. If I is 15 milliamps and R is 6 kiloohms, find the power being dissipated. Okay, P is equal to I squared R. Okay, so in this case, I is 15 milliamps, so we have 15 times 10 to the negative 3. That has to be squared, and then we have to multiply that by 6 times 10 to the third. So maybe we should use the calculator here. Okay, so here's my scientific calculator. Just about any scientific calculator you see, it's going to have a means for entering scientific notation. On my calculator, this little Casio, the button is down here, EXP, that tells the calculator you're about to enter scientific notation. Okay, so I want to do 15 times 10 to the negative 3 and then square that. So 15, and then I press that EXP button, and that gives me this little E here, and that's just calculator shorthand for multiply by 10 to the power that I'm about to enter. So you go negative 3. Notice when you enter a power, you use the little negative up here, not the minus sign. Okay, minus is for subtraction. This is for entering negative numbers. Okay, and now I need to square that. And that gives us 2.25 times 10 to the negative 4. Okay, so you see, I don't know if you can see it, but you have the times 10 here and then the exponent negative 4. Okay, now I need to multiply this by the resistance. And in this particular case, the resistance was 6 kiloohms. Okay, so I'm just going to press the multiply button, and that will automatically multiply it by my previous answer. See the ANS here, that means pull back the answer that I had before, so I don't have to retype it. And then 6, E3. And that means 6 times 10 to the third. And then equals, the answer is 1.35 watts. Okay, and in the notes I've rounded it off to 1.4. Okay, let's do one more example using that formula. The power dissipated in a resistor is 22 watts, and the resistance is 2.2 kiloohms, and I need to find I this time. Okay, well, I still have the same formula, P equals I squared R, but this time, instead of needing to find the power, I'm given the power, so I have to fill in 22 for that, and I'm going to fill in 2.2 kiloohms, so 2.2 times 10 to the third for my R, and my current is unknown, isn't it? So I have I squared times 2.2 times 10 to the third. So now I'm going to need to solve for this current. So to do that, I'm going to divide by the 2.2 times 10 to the third. So I have 22 divided by 2.2 times 10 to the third, and so that gives me 0.01. So I have 22 divided by 2.2 times 10 to the third, that gives me 0.01. And that is I squared. Of course, that's not the final answer. How do we get the final answer if we know I squared is 0.01? Well, we have to take the square root, don't we? So I is equal to the square root of I squared, the square root of 0.01, and that is square root of 1 over 100, which is 1/10. So the answer is 0.1 amp, or 100 milliamps. And I have sketched the solution here in the notes.